Chapter 1, Lesson 6, Video F. This is the final in the series of lectures, so we'll go ahead and take a look at analyzing diagrams. And this is a really important lesson because it's going to be, as I said, the focus of the course in geometry is giving reasons. And so you're going to have to be asked, well, why? How do you know that? How do you know that? How do you know that? And so you have to be able to give a mathematical reason, as we talked about, a theorem, postulate, a definition, to support your mathematical expression, whatever that may be. There are also, when looking at diagrams, it's going to be very important to know that there are certain things that you can assume and certain things that you cannot assume. And a lot of times in geometry course, a lot of students will take that what their eyes see as being truth. In other words, when I look at a diagram, I'll say, well, those two sides look equal, therefore they must be equal. And, well, what's your reason? And the only reason in that case is because, well, it looks like it. And that's not a good enough reason. There has to be some kind of mathematical definition, theorem, postulate, or some kind of mathematical notation that allows us to make that assumption. We can't just do it because it looks like it. And a lot of times in this course, you're going to be able to arrive at the correct solution based upon what it looks like. But because you don't have the mathematical notation or definition behind it, you can't make the assumption. And so I'm going to have to say, well, no, yes, numerically the answer is 6, but if you can't explain to me how you get to 6, then you're not understanding the geometry. So there's some things about a diagram, and this is in your book. There's 3 things that when you look at a diagram, it's okay for you to go ahead and assume. Even though it's not marked in any way, you can go ahead and make this assumption. And then there are 3 things that you cannot assume when looking at a diagram, and then I'll give you a few examples. So let's first look at the 3 things that it's okay to conclude when you're looking at a diagram. First of all, if you're looking at a diagram, it's okay to assume or to look at the diagram and see adjacent angles. And if you remember from adjacent angles, they're angles that share a side. So here over on the right, angle 1 and angle 2 are adjacent. I know that just by looking at the diagram because I can tell that they share this side right here and there's nothing in common and they have the same vertex. Same thing with 3 and 4. I can go ahead and assume that or make that conclusion that they have the same vertex. I can trust my eyes. They share this side. I can trust my eyes. And that they don't overlap. I can trust my eyes. That's okay. So that's okay to do. The second thing that it's okay to do is to look at 2 angles and assume or to conclude that they make a straight line. So again, if we're looking at angles 1 and 2 here together, I know that there's adjacent. I can tell that this is a straight line basically because these arrows are on it. That helps me, but I can see if I took this angle and this angle together, they would make this straight line. So that's okay to go ahead and make that conclusion, which is going to be very helpful because I know then that angle 1 plus angle 2 equals 180, which again is a mathematical expression, an equation that I need in order to determine a variable. And then I can look and determine vertical angles. Anytime 2 lines cross, we know we have vertical angles. So here I have intersecting lines, so I know for certain that 1 and 2 are vertical angles and 3 and 4 are vertical as well. So those 3 things it's okay to go ahead and look at. And notice none of those really have anything to do with the measure of anything other than this straight line, which we know is 180. And that's really what we have to stay away from, is assuming that we know what the measure of something is. Okay? So the things that we're not okay to do, we cannot conclude congruency. In other words, I can't look at a diagram and say, well, those look to be equal, therefore they are equal. You can't do that. Now, they may end up being equal. I get that. But that's an assumption you can't make. You have to have a definition, theorem, postulate, which allows you to do that, or some kind of notation within the diagram, or maybe a given that tells you such and such are equal. So you can't just look at things and say, well, they look to be equal, therefore I can assume they're equal. The second thing that you can't assume is that you have a right angle. Okay, just because 2 lines look like they form a right angle, you can't make that assumption. And again, the only way to know that is to be given some kind of notation. And you remember the right angle notation or the right angle marking was that little box on the angle. So real quick, if I was to do this, so this little thing marked, that tells me that those are right angles for certain. If I didn't have that mark, let's see, if I didn't have that, if I just had this, I can't say for certain that that's a right angle, even though I may want to. And the last thing we can't determine is whether lines are parallel or perpendicular. Okay, parallel we've talked about before. Two lines don't intersect. I cannot make the assumption that these lines don't intersect, even though they look to be parallel. I can't make that assumption. There must be something within the diagram or something within the problem that states that those are parallel. And then perpendicular we haven't talked about much yet, but we will. It's the same thing. You can't make that assumption. So let's take a look at a diagram and do a few practice things and see what we can and cannot assume. Remember, everything's got to go to a definition, postulate, or theorem. So the first question is, can you say for certain, with a definite reason, that PQ bisects TV? So remember, bisects means cuts in half. So does PQ cut TV in half? So PQ is this line segment right here, and this is TV. Does PQ cut TV in half? And if so, how do you know? And the answer here is yes, because these tick marks right here, they tell me that TW and WV are equal segments. And if this thing has been cut in half, these segments should be equal, which they are, and I'm told that by the notation in the diagram. So yes, I can go ahead and say that those are congruent, and my reason is because they give me the tick mark. They tell me that's shown in the diagram. Okay, let's do another example. Does TV bisect PQ? So what does bisect mean? Cut in half. So does TV cut in half PQ? So does this cut this line in half? Now the tendency is to want to say, well, yeah, these two things look equal, but how do you know that? There's no notation that tells me they're equal. There's no tick marks that tell me they're equal. There's nothing that says this is 4 and this is 4, so I have absolutely no reason to make the assumption that these two are equal, other than if I just want to say, well, it looks like it, and in geometry we're not allowed to say that. We have to have a mathematical reason, definition, postulate, theorem, or some kind of notation that allows me to make that statement, and in this case we don't, because we don't have any markings that tell me otherwise. Okay, we can't go based on our sight. Let's see, how about this? Is TV perpendicular to PQ? Now perpendicular means that they make 90-degree angles. So is TV and PQ, is this angle here a right angle? And again, it looks like it, but without the notation, I cannot say for certain. There is no right angle mark, therefore I cannot make that assumption. So there are, again, no markings. I can't assume it. Let's do one more. Is PW congruent to WQ? And again, it may look like it to my eyes, but without any markings, without any kind of definition, theorem, or postulate, I cannot make the assumption of congruency. So PW, does it equal WQ? I don't know. Can't make the assumption, so we know we don't have any markings. We don't have any way to know that. Okay, so those are some examples of things that you might want to assume that are true because they look like it, but you can't do that. So be very careful of that as we go throughout the year, because I'm going to ask that for quite a bit, quite a number of times. That was my dog. He's getting fed, so I hope you enjoyed that. We'll see you in class.